Good afternoon all of you. Basically this is a orientation class and here we discuss a separate topic, limit, continuity and differentiability. Limit. So basically here we have to know limit of a function. How limit of a function work. Limit of a function means behavior of a function at a particular point. Means that at a given point, how the behavior of a function changes. For example, let us take a graph. Suppose this is a y equal to f of x, any given graph. Okay. We have to know the behavior of a function. This is x-axis and this is y-axis. We have to know the behavior of a graph at x equal to a. So we check the value of a function at x equal to a plus and x equal to a minus. If the value of a function at x equal to a plus and x equal to a minus does not change, then limit exists. If the value of a function changes, then limit does not exist. So if we discuss it as mathematical expression, so limit x tending to a plus f of x is equal to L. Let here L is any finite value and limit x tending to a minus f of x is equal to L. If these two limits, limit x tending to a plus, limit x tending to a minus, if these two limits are same, the value of these two limits are similar, then limit exists. If the value does not same, then the limit does not exist. Now we take an example where the limit value left, basically this is the right hand limit and this is the left hand limit. Now we take an example where the right hand limit and the left hand limit, the value of the right hand limit and the value of the left hand limit does not similar. X-axis, y-axis. Now we take an example like this. This is a given graph, y is equal to f of x. And we have to check the value at x equal to a. So if we move further, x equal to a plus, the value is like this. And when we move here at x equal to a minus, the value is something like this. Here the left hand limit and the right hand limit does not same, so limit does not exist. Before going further, we have to know some graph, some important graph, because some example in a limit, in a differentiation problem, in a continuity problem are so complex. So without knowing the graph theory, you cannot handle these problems. So here we discuss a graph theory. Number one, let us take y is equal to mod of x. here we represent mod of x in a graphical form. The graph of mod of x at x equal to 0, value is equal to 0. So if we check the limit at x equal to 0 on mod of x, like given f of x is equal to y is equal to x, we have to check limit x tending to 0 mod of x. So here we can see that at x, when x is greater than 0, mod of x is equal to x. When x is less than 0, mod of x is equal to minus x. So when we check limit x tending to 0 plus, mod of x is equal to x and its value 0. When limit x tending to 0 minus x, but at x equal to 0, the value is 0. So here limit exists, but we have to know the value, the behavior of a function at given point. So this is the graph of y is equal to mod of x. Now take a second example. Y is equal to e to the power x. E to the power x. The graph of y is equal to e to the power x is like this. At x equal to 0, y is equal to 1. When x tending to infinity, y tending to infinity also. And x tending to minus infinity, y tending to 0. So these two limits, when x tending to infinity, y tending to infinity, and when x tending to minus infinity, y tending to 0 are most important. Okay? Now we move further and we have to check here y is equal to e to the power minus x. The graph of y to the power x is reversal of the y to the power e to the power x. Here the y to the power e to the power minus x is like this. Where when x tending to infinity, y tending to 0. When x tending to minus infinity, y tending to infinity. These two limits are also important. Now we check one more important graph. Number 3. Number 4. Y is equal to 1 upon x. The graph of y is equal to 1 upon x is shown as like this, where x tending to infinity, y tending to 0, x tending to minus infinity, y tending to also 0. Okay? One more important graph, y is equal to log of x. This graph is also important for limit problem, for differentiation problem, and for definite integration problem. We have to know this graph. The graph of y is equal to log x look like this, where at x equal to 1, y equal to 0. So this is the graph of y is equal to log of x. Okay. So these are some basic important graphs we have to know before solving the differentiation problem, before solving the limit problem. Now we take an example of a limit. How to solve